This video explains the importance of the process of evaporation with reference to the case of Lake Mead. To understand the problem, you need to know a little bit about US Southwest water allocation. And so about 100 years ago, the Colorado River water rights were allocated to 7 Southwest states. To allocate the water, they needed to know how much was available. And so stream flow over the previous few decades provided the basis of the allocation. They thought they had an average of about 20.2 million cubic dam, which is about 20 cubic kilometers. The upper basin states were allocated almost half of it, the lower basin states almost half, and Mexico got about 10%. Okay, so this is the set of basins, the upper basin, lower basin, and the portion that comes from Mexico. What they didn't know was that actual average flows over the past few centuries were significantly lower. They were about 16.7 cubic kilometers. And so before they even started, the Colorado River was actually over-allocated. And with rising population and rising economic activity in the US Southwest, this could be a problem. Further, according to tree ring records, in severe droughts, the stream flow can be as low as 5.4 cubic kilometers, so roughly 1/4 of what was allocated. And so if states were to experience drought this severe, they would have extreme water shortages. Think about all the fountains and so on in Las Vegas. This would be a problem. And that's not even a large water use compared with irrigation water uses, for example. The primary reason that there are no current shortages in the US Southwest is the large amount of storage in Lake Mead, which is behind the Hoover Dam, and Lake Powell, behind the Glen Canyon Dam. These provide a large buffer against drought. However, with temperatures expected to increase 7 to 8 degrees Fahrenheit, about 4 degrees Celsius by the end of the century, increasing evaporation rates from reservoirs and canals, combined with a fast-growing population and predicted decrease in precipitation, this buffer is probably not large enough to sustain the region in the 21st century, according to Sarah Leroy. Now we need to know a little bit more about Lake Mead itself. Lake Mead is the largest reservoir in the United States by volume. As you know, it's located on the Colorado River. It has a reservoir that's 180 kilometers long. It is fairly narrow, but it is 180 kilometers long when it's full, and its maximum depth is about 149 meters at the deepest point. Note that it can hold a maximum of 32 cubic kilometers. It hasn't, however, been that full since 1983, so going on 40 years. And it's used for a number of purposes: for flood control, for municipal and industrial water supply, for irrigation, and for power generation. So then, with so many critical water uses, evaporation could be a potentially significant loss. And so we wonder, how large are the evaporation rates for Lake Mead? Lake Mead has experienced pretty significant falling water levels over the past, well, 20 years anyway. Okay, so here you can see the level in 2000 when it was right up about here. Okay, so fairly full at that point. Down to 2004 when they started to be concerned about falling water levels, and then it reached a minimum around 2014 or 2015, which is when there was a lot of discussion about Lake Mead water levels. So you can see an explanation of the problem and their water management efforts to date in this video from the Brookings Institution. I recommend watching it. And here you can see part of the problem, although it's probably not a very significant water use here. These are very green lawns in a very desert environment. And these rings are interesting as well. This is called the not very technical term of bathtub rings, and they're mineral deposits left by the water at its high level mark, which is up here. So you can see it's fallen very significantly. These are ships, I believe, the little dots. So then, with limited water supply, we wonder, what is the annual evaporation and how much is lost from Lake Mead on an annual basis from evaporation? So at a water surface elevation of about 330 meters, uh, the surface area is about 34,000 hectares. If you want to imagine the size, this is a square of about 18.5 kilometers by 18.5 kilometers. At its full supply level, which is significantly higher, almost 375 meters, the surface area is about 66,000 hectares, or in other words, a square of about 25.7 by 25.7 kilometers. And so elevation makes a difference for surface area that's exposed to the atmosphere, which affects the amount of evaporation that occurs. Here are typical evaporation rates for the area. So you can see it varies over the course of the year. We'll talk more about this during the evaporation topic. And its average is about almost 90 inches per year of evaporation, or 2.28 meters of evaporation off the surface, which is about the height of the room I'm in right now. And so with that amount of evaporation off this surface area, how much water loss are we looking at? And it turns out it's over 3/4 of a cubic kilometer per year for the relatively lower level that was experienced in November 2009. For the January 2012 level, almost 1 cubic kilometer in a water scarce area was lost just from the reservoir surface. And then at full supply level, which again hasn't been achieved in a long time, it could be as high as 1.5 cubic kilometers of water loss. And that's almost 5% of the total volume of the reservoir lost through evaporation. Policymakers are becoming concerned in the area about water loss from evaporation. And so to make sure that they can extract every drop of water from Lake Mead, they're now putting an intake pipe at the bottom of the reservoir, like a bathtub plug. Okay, here's a video that shows a little bit about that process. Here we are basically at the end of the line. So this is the bathtub plug. And I'll leave you to watch the video here to learn a little bit more about it. Okay, so I hope this video has helped to set the context for evaporation. We're going to start on the topic very shortly in the next set of videos.